Millions of people visit Yellowstone National Park every year to take in the scenery and spot the local wildlife. As they wander these quiet pathways, most have no idea they are walking directly above one of Earth's largest and most active magma systems. To understand Yellowstone, one must look past the picturesque scenery at a dormant, world-altering force of nature. When you picture a volcano, you likely imagine a towering, cone-shaped mountain. Yellowstone has no such visible peak. Most of its massive structure is hidden underground, sprawling wide across the borders of Wyoming, Montana, and Idaho. Despite its scale, active monitoring shows no evidence that a catastrophic eruption is imminent. Yellowstone operates as an expansive geological engine integrated into the foundation of the continent. Geologists classify Yellowstone as a supervolcano because it is capable of producing an eruption exceeding 1,000 cubic kilometers in volume. That volume of material is thousands of times larger than any ordinary volcanic eruption recorded in human history. This cross-section shows the mechanical process. Rising magma fills a subterranean chamber, building extreme pressure until it violently forces through the surface crust. Once the chamber is emptied, the ground above loses support and collapses inward to form a massive depression called a caldera. Today, the Yellowstone caldera left behind by previous eruptions measures roughly 45 miles across. A crater that wide is larger than many major modern cities, demonstrating the capacity of this mechanism to reshape planetary geography. This landscape has been ruptured by 3 distinct super-eruptions over the last 2.1 million years. The heat from those ancient cataclysms remains trapped underground, actively powering the park's surface environment today. When that heat interacts with local water sources, it creates surface phenomena like these boiling mud pots. The most famous example is Old Faithful, an iconic geyser that vents boiling water high into the air on a regular cycle. All of the park's celebrated beauty is a visible result of immense, violent energy temporarily at rest. Because of that energy, researchers have modeled what would happen if this system erupted today. Enormous amounts of volcanic ash would blanket significant parts of North America, disrupting logistics and immediately grounding air travel across the continent. The fallout would reach far beyond the park, as thick layers of ash would cripple broad-scale agriculture in the affected regions. Additionally, volcanic particles suspended in the atmosphere would block sunlight, causing a temporary decrease in global temperatures. These devastating models represent absolute worst-case scientific scenarios, and they highlight the importance of the constant monitoring currently in place. Internet videos frequently claim that Yellowstone is overdue for an eruption, but scientists find no evidence to support that claim. Volcanoes do not operate on fixed, predictable schedules, and the time between past eruptions has varied by hundreds of thousands of years. Instead, the United States Geological Survey maintains a dedicated watch over the area to track its actual physical behavior. They measure ground deformation with GPS and satellites and record tremors using a network of seismographs. While thousands of small earthquakes hit the park every year, those swarms are normal background noise for an active geothermal region. If a super-eruption were building, we would see clear, escalating warning signs like extreme ground uplift and drastic changes in gas emissions long before any real danger arrived. Current data confirms the system is stable, allowing us to view Yellowstone as a massive, functional masterpiece of geology. Visitors will continue to walk atop this sleeping giant, supported by a network of scientists watching its every move. It remains a powerful reminder of the unseen forces shaping our planet just beneath the surface.